Okay, pre-calculus review. These are the next set of questions. This is seeing whether you can memorize basic facts about sum and difference of cubes and following directions. So it's real key to follow directions here, otherwise you won't get any credit. There's no partial credit for these problems. Okay, so for the first part, it just says factor the cubic expression x cubed minus 64. If you go x minus 4 times x squared plus 4x plus 16, and you leave it that, you get 0 credit because you didn't follow the directions. So let's look at the directions. It says, as a product of a linear and a quadratic. Okay, we got that. That's linear, that's quadratic. What's wrong? Start your answer with x cubed minus 64, then an equal sign, and then the two factors. So to get credit, follow the directions. Start with x cubed minus 64, and then an equal sign, and then the two factors. And you're good, full credit. Easy problem, follow the directions. Number 2, the quadratic expression you wrote, or the quadratic factor you wrote, remember this was the linear one and this was the quadratic one. The quadratic factor you wrote in problem 13 is called irreducible. It's just vocabulary from Algebra 2. You don't need it for this problem necessarily. Now, why is it called irreducible? Because it cannot be factored using real numbers. So you cannot break this up using real numbers. You can break it up if you use complex numbers, but we're not going to do complex numbers on this exam, so we're just real numbers on. The quadratic formula can be used to find the solutions to quadratic equations. Okay, so what's the quadratic formula? I know that. That's that negative b plus minus the square root of b squared minus 4ac all over 2a. I remember that back in the end of Algebra 1, or certainly Algebra 2, you remember that. So I write that down and I get 0 credit because I didn't follow the directions. Complete the quadratic formula. If ax squared plus bx plus c equals 0, then what can you say? You can't say that. What you can say is that x is equal to that. So you have to have the x part and you have to have the equals. I mean, you know, this is a general relationship between the variables x and the coefficients a, b, c. So you've got all the coefficients a, b, c in here, but you got to say it's equal to what x is. So that's the key part of the quadratic formula. Okay. Number 3, the discriminant, again, a vocabulary word from Algebra 2, is the part of the quadratic formula under the radical sign. So here's the quadratic formula, here's the radical sign, and so the discriminant is equal to this part underneath the radical sign. That's what it says. Part of the formula under the radical sign. And then you're just asked to calculate the discriminant for the quadratic factor you wrote up in problem 13. So we're going back to this guy and we're trying to figure out what the B and the A and the C are. So hopefully you know that this is the B number, right? This is the C number, and the A number would be represented as a 1. We normally don't write that, but that's what A is. So we got A, B, C, 1, x squared plus 4x plus 16, and our task is to go ahead and calculate the discriminant, okay? Follow the directions. Start your answer with b squared minus 4ac, then an equal sign, and then the correct substitutions and simplification. So we have to plug in the correct A, B, C. Let's see, B was 4, so I'm writing 4 squared. Now, it's a positive 4, so we can just write 4 squared. If it were a negative 4, we would have to make sure we do that, right? Because this is not the same as that, right? So just be careful with negative signs, but we don't need that here. It's just 4 squared. And then minus 4 times A, we said was 1, and times C, we said was 16. Okay, so we've written the b squared minus 4ac, then an equal sign. We put in the numbers, but now it says we have to simplify. So let's go ahead and clean that up. Let's see if we can get that out of the way. So we have 16 minus 64 is minus 48. Okay, done. We've completed problem 15. And by the by, looking back at it, because this is under the radical sign, right, we're trying to take the square root of a negative. That's why this has no real solutions. That's why this is irreducible, right? We can't break it up into real numbers. because there's going to be complex numbers involved in there. So there's no real solution if I said, make this thing equal to 0. You can't, right? Unless you go out of the real number system. Okay, number 4, or I guess number 16. The original cubic expression appears in this equation, x cubed minus 64 is 0. This equation can be solved by factoring, as you did in problem 13, and then setting each factor equal to 0, then solving each of the simpler equations. Solve the equation by factoring. So we have x cubed minus 64 is equal to 0. We know how to factor it. X minus 4 times x squared plus 4x plus 16 is equal to 0. And then it says set each of individual factors equal to 0. This one, x minus 4 is equal to 0, so x is 4. That's one of the solutions. And then this one's problematic, right? So we have x squared plus 4x plus 16 is equal to 0. And we already know what happens to that, right? Because we looked at it up here. If you've got ax squared plus bx plus c is equal to 0, then x is supposed to be this thing. And we've already worked that out, at least the discriminant part. We know it's a negative number. So when we get down here, this has no real solutions, right? Because we're having that square root of the negative 48 in there. So no real solutions for that part. It does say use only real numbers. This is the answer. So x is 4, done. The quadratic part, we don't get any real solutions there. Okay, the last part of this, number 17, the equation x cubed minus 64 equals 0 can be rearranged, right? So we got x cubed equals 64, and then solved using power equation techniques, raising both sides to the same power. So we're going to take the x cubed and we're going to take the 64, and we're going to raise both of those to the same power. Now, the power equation techniques, you can raise it any power you want and raise it to the 10th if you want. That would be legitimate. But to solve it, we need to raise it to the reciprocal power, to the 1/3 power, right? Because you multiply the exponents here, so this gives us x to the first, and we get the cube root of 64. It does say simplify, right? So cube root of 64 is 4. I mean, it's not surprising we're getting the same answer as we got up here. X is 4, that's the only real solution. Okay, so quick problems. That shouldn't take you, more than 2 or 3 minutes as long as you follow the directions.